Stop and think about the heart for a second. It's just this tireless pump, right? Constantly filled with blood, moving it through its chambers, 247. So here's a question that might seem a bit counterintuitive, and it really kicks off our deep dive today. If the heart muscle is literally swimming in oxygen-rich blood all the time, why on earth does it need its own separate dedicated plumbing system just to stay alive?
That is really the fundamental question for understanding how the heart works and, frankly, how it fails. So today we are taking a deep dive into what's called the coronary circulation. Think of it as the heart's own internal highway system. Our mission is to unpack the anatomy, the arteries and veins feeding the muscle itself. We'll define this concept called coronary dominance and, maybe most importantly for you listening, explain exactly why problems here, structural vulnerabilities, can lead to really catastrophic heart events.
Okay, so just to set the stage, maybe let's quickly contrast the big circuits we usually talk about. You've got the systemic circulation, heart to the body tissues and back, and pulmonary circulation, heart to lungs, back to heart.
Exactly. And the coronary circulation is kind of the third, often forgotten circuit. It's the one that goes from the heart directly to the heart tissue and then right back into the heart. And the reason it's absolutely essential is, well, it's physiology. The heart muscle, the myocardium, it's just way too thick. Oxygen can't just soak in, diffuse from the blood that's rushing through the ventricles. The inner layers would starve pretty quickly.
Right, and it's not just the thickness, is it? It's also the force. The pressure inside those pumping chambers is huge.
Immense. That pressure and the speed of the blood flow, it physically prevents any real gas exchange from happening directly through the chamber walls. It's just too high pressure, too fast for that kind of passive diffusion.
So you need a dedicated delivery system.
Precisely.
Yeah.
To nourish that thick myocardium and also the outer layer, the epicardium. So oxygenated blood leaves the aorta, goes into these special coronary arteries, feeds the tissue, and then the used blood comes back via cardiac veins straight into the right side of the heart, the right atrium. It's a completely separate loop just for the heart muscle itself.
Okay, so let's start unpacking the vessels, the arteries first. And you mentioned a key vulnerability right at the start. These coronary arteries, they're classified as end arteries. What does that actually mean?
Yeah, that term end artery really signals the danger. In this context, it means they supply a specific patch of heart muscle without enough overlap or connections. Anastomosis is the technical term from neighboring coronary arteries. Functionally, it means there isn't really a good backup route if the main path gets blocked.
And that's where the clinical danger comes in, right? Because if you get a blockage, like a clot or plaque, the tissue downstream it can't get blood from anywhere else.
That's the crux of it. When that blockage happens, the tissue downstream suffers immediate ischemic damage, lack of oxygen, because blood can't flow backwards or retrogradely through those few tiny collateral connections that might exist. They're just not sufficient.
Ischemia, okay. And that damage, that's what we call a heart attack.
Exactly. That damage is the heart attack, coronary attack, myocardial infarction,